Hi again. Here we are in the third and last part of the static coefficient of friction experimental measurement. Okay, there are two more videos, one that explains the physics and the mobile phone use, another one that started with the Excel, and this one that is going to finish the Excel calculations. So let's go to the Excel website, to the Excel document, sorry, that was, my God, that was here. Okay, here we were calculating, and you have to find the x, the gy, the gz, then do the division, then measure the angle, and then you are going to do all this in a new page. Okay, with the experiment 2, then you have to do the same with experiment 2, then with experiment 3, with experiment 4, because you had to have the experiment 2, okay, all the data of the experiment 2, the same with experiment 3, the same with experiment 4, okay, the experiment 5, that I had already done this. So you have all these experiments, you need 10 of them, okay? When you do that, when you do the 10 of them, you are going to have something like this, where you have all the 10 experiments, you have measured the gy for each of the experiments, the gz for all of the experiments, and then you have calculated, okay, the tangent of the angle for all, and then this is going to be equal. So if you see this, okay, of course, this is the division of this column, okay, this column, this line, sorry, okay, and here what we have is the division of gy divided by gz. Okay, you know that when you have done one, you only need to drag. Okay, and the same here, you have the arcotangent of each event, and here we have calculated the angle in degrees. Okay, with all the measurements, and then the static coefficient. It should be the same, but when you do experimental measurements, normally you don't have the same calculations. So what are you going to do now? You're going to do the average. The average is la media, okay? The Excel makes this for you. So what are you going to do? You're going to say, okay, here we are going to find the average of what? Of all these measures, okay, all of this, and then a set, and then it gives you 0.3612. So this is going the result that we were trying to find. Okay, we can do more things. We can calculate the error, the relative error for each of these measurements to see if they are good or not. Okay, you can add here, for example, the error. You want to calculate the error. It is going to be equals to this minus the absolute value. Sorry, this minus this. Okay, but you know that you have to do the absolute value of this. Okay, the absolute value of s to be sure that we don't have a sign here, right? As we did with the angles. And then you have here that, okay? You have to do this for each of them to calculate it. And then the relative is going to be the absolute error divided by the original one times 100. And this is the relative. Okay, so it is 3.36%. Okay, this is the percentage of the mistake of the error, which is not bad. Okay, and you can do the same for all, right? But okay, what we wanted to calculate was the static coefficient. okay? That is the tangent of the angle when the movement starts, okay, in this moment. So here it is. With this, we have finished our project. Thank you for watching. See you in new videos.